Welcome to Building Connected Data with PD&M. We're going to give another minute or two for people to trickle in, but we will be starting shortly. Thank you. All right, we're going to get started. So welcome to Building Connected Data with the Product Design and Manufacturing Collection. Before we get started, a little bit about us. M2 Technologies is a consulting firm focused on productivity, improving manufacturing process efficiency, and reducing manufacturing costs. Using generative design and best-in-class manufacturing and asset management processes, our team of industry experts can help you become more sustainable, more profitable, and more prepared to meet the demands of urbanization in a rapidly changing world. We are committed to helping clients realize the business benefit of BIM and asset management quickly and economically by facilitating the use of innovative processes and technologies. Whether it's streamlining your product design, maximizing asset longevity, or optimizing your processes, our team is one of the most experienced groups of manufacturing technology consulting professionals. We partner with world leaders such as Autodesk, Panzura, and Eagle Point to utilize innovative technologies and methodologies to empower sustainable manufacturing and overcome local challenges. To help meet the needs of the industry, we provide services in CAD management, data management, generative design, CIO advisory, and much more. My name is Tristan Gunderson. I'm an applications engineer here at M2 Technologies. I work with our clients to help them optimize their workflows, get the most out of their software, and utilize cutting-edge technology. So a little bit of what we're going to be covering today. We're going to start by looking at the product design and manufacturing collection as a whole. From there, we'll look at the Inventor ecosystem. We'll go into workflows and pathways within the product design and manufacturing collection for 2D and 3D modeling. And then lastly, looking at building infrastructure management and beyond. So to start, we can see here's all of the included software for the product design and manufacturing collection. This includes some key products such as Inventor, Fusion 360, 3ds Max, AutoCAD, and Navisworks. We will be covering at least a little bit of most of these products today. The exception being 3ds Max, which is a rendering tool that can take your models from other programs or be made within it in order to create high detailed renderings and graphics. Now we're going to get started looking at the Inventor ecosystem. So Inventor is really at the heart of the PD&M collection. It has direct connections to most of the products in it, some of the main ones being connection to Vault Basic, which is included, and Fusion 360. This allows for expanded use, especially within the data management realm with Vault Basic. While many people like to move from Vault Basic to Vault Workgroup or Vault Professional, Vault Basic does give the basic tools needed for your data management, store your files, allow for check-in and check-out so that you don't have people overwriting or losing items within a network drive. On the other side of that is Fusion 360, which also can be used for data management with the Fusion Team extension. In Fusion Teams, you have a cloud-based storage for all of your items, including Inventor items. However, some of the key tools within Fusion 360 that help benefit even within users of Inventor is its PCB board design tool, its additive manufacturing for 3D printing of plastics or metals, and its generative design functionalities, which allow you to use computer aided design and algorithms to help create new and original designs to optimize your products. Beyond just the connections, though, to Vault and Fusion 360, there are 4 key products in the PD&M collection that you cannot get anywhere else. While you can get Inventor Professional by itself, the Inventor Tolerance Analysis, Inventor Nastran, Inventor CAM, and Inventor Nesting are all exclusively provided within the PD&M collection and work as add-ins within Inventor itself. Let's start looking at Nastran and Inventor Tolerance Analysis. So the Inventor Tolerance Analysis analyzes model dimensions and tolerances across a single part or a full assembly to look for areas where tolerances can be improved, where you're getting tolerance stack up because of a series of dimensions with tolerances, and helps make suggestions as to how to prevent those stack ups or improve overall efficiency. It also allows you to verify consistency, part fit, and the interchangeability of components across a design by looking at interference, looking at use case. You can select items such as having uh, a snug fit or a looser fit for a shaft, for instance, and it'll give suggestions as to what tolerances will best achieve what you're looking to do. Next, we have Nastran. So Nastran is an extended FEA simulation add-in for Inventor. Inventor does have a couple built-in simulations for linear stress and modal analysis. However, with the expanded capabilities of Nastran, you can run simulations on your parts and assemblies anywhere from that linear and nonlinear stress to look how loads, bending, or even thermal expansion will affect the stress on a component and if it will fracture, all the way to the modal and frequency response. You can use those to look for natural frequencies and what the stress response to frequencies, either the natural ones or ones that you know are being created by moving components such as motors within your assembly. You then have impact analysis, looking at drop tests or the impact of moving components, and heat transfer. So you can actually look at the effect of heat being given off by electrical components or a motor within the larger assembly. And these are only a select few of the many simulations and analyses that can be set up and run within Nastran to help you get a better idea of how your parts and assemblies are functioning before you move into the physical prototyping stage. We then have the Inventor CAM and Inventor nesting. Both of these are tools to help us prep for any kind of CNC machining operation. The key with having this built-in CAM and nesting tool is as we make changes to our parts and our designs, we're able to automatically push those changes through to our CNC coding, so we can rapidly recreate those G codes for the slightly altered parts or tweak small components of that code. Within Inventor CAM, we have everything from 2 or 2.5 axis milling all the way up to 5 axis milling, including turning, 4-axis milling, also sometimes called indexing, or 2+3 axis milling, depending on what kind of machine you're using. And it has specialized tool for adaptive clearing and finishing parts. So there's a lot of automated processes built in. You can select features and it will create those paths all on its own to help optimize your tool paths. Inventor nesting, on the other hand, is designed for creating sheets. It can be created with 3D components, but typically for 2D cut components. But it'll help you lay those out in a optimal pattern across the series of sheets. It allows for inputs of if you need a certain grain direction, if you need things to have spacing in a certain way or fit together, if items can be cut out of the gaps in other items. All of that can be set up and it will help you create those optimized sheets so that you're really getting the most out of your material when you move to your cutting operations. From there, you can move that nested component straight into Inventor CAM or Fusion 360 to create those CNC paths, or you can export it as a DXF so you can input it into any other program for creating those pathways. So that kind of is going to wrap up our core Inventor ecosystem. But beyond Inventor, one of the key products is AutoCAD. And AutoCAD has been used for decades. It is really one of the core products of the industry. And a lot of companies, for instance, will have a lot of legacy AutoCAD drawings, and as they're moving into the PD&M Collection or moving into Inventor, they're trying to move those 2D drawings to the 3D. And the connections between Inventor and AutoCAD make this really easy. Within Inventor, you're able to import your AutoCAD DWG drawings and then use those drawings to create the 3D geometry without having to remodel, redimension any of the components. And really the key with this is it comes in as an associative drawing. And so what that means is it is pulling all of these dimensions, all of these features, references directly from that AutoCAD file, and that connection remains even once you've created the part. So we can use this, we can create those 2D geometries, we can place it on a sketch plane, extrude, any other tools we want. But one of the really important things is when we have those multi-view drawings, as you can see on the side here, we're not only able to just pull out a single starting shape from one drawing, we're able to use those different views of the drawing to really build the part from those drawings exclusively without having to reinvent the wheel, so to speak. And lastly, like I said, with that associative with it being an associative drawing, if we do go back and make changes to the AutoCAD DWG file, we're able to push those changes forward into our Inventor model because it is all built off of those original drawings. We're able to bring that forward and maintain those changes. Beyond going from 2D to 3D, we actually also have the capability of going back the other way. The simplest form of doing this is we can take a Inventor drawing, which can be created as a IDW or as a DWG natively within Inventor, and then we can open those up in AutoCAD. And so when we do so, they'll look relatively the same, but since it is created in Inventor off of that 3D model, that means that any changes we make to the model will be pushed forward to Inventor and then pushed into the drawing in AutoCAD as well. So if we have users, for instance, on the shop floor who only have access to AutoCAD, so they're looking at these drawings in AutoCAD exclusively, any changes made within Inventor will automatically be seen by them, and we can maintain that communication and those workflows. Lastly, if you're looking just to take a part of a 3D model and export it, we do have the export face tool as well. This is not associative. You would need to push additional ones forward if changes are made, but this is really useful, if we're making any kind of nesting in a separate program or doing 2D cutting, or just want to move just a single face of a drawing into AutoCAD. All we have to do is just right click on that face. You select export face as, and you save it as a DXF, and you now have any face. It doesn't have to be along one of the planes. Sometimes it can be hard to get a specific view in a drawing if you're in AutoCAD. But with this, we can really select any feature that we want and create that as a drawing element. And then lastly, within the Inventor AutoCAD ecosystem we're going to talk about here, we're going to talk about AutoCAD Electrical. And so AutoCAD Electrical is included in the AutoCAD with tool sets, which is the version of AutoCAD available in the PD&M collection. So when you get the PD&M collection, you don't just get AutoCAD, you get AutoCAD Electrical and AutoCAD MEP as well. And this connection between AutoCAD Electrical and Inventor really is something special, because what we're able to do is we can link our wiring diagrams in AutoCAD Electrical directly to our Inventor models, and this allows us to communicate back and forth between our mechanical and our electrical engineers and be working on the same product in both 2D and 3D representations. So how this works is within Inventor, we can create or place electrical catalog components. These work very similar to your standard component libraries of nuts and bolts. However, these components are really special because as part of them, they have these established pin locations and numbering schemes. So this tells us where our wiring will connect to the component and what that connection looks like on our wiring diagram. So these components are going to have the same pin numbering across Inventor and AutoCAD Electrical. So as we create those wiring schematics in AutoCAD Electrical, we are connecting it to the pins that also exist in Inventor. So once we link those, we have our electrical components from the catalog set up in Inventor. We're going to see a list of all of those components that we brought forward from our wiring diagram. And if we have multiple instances of those same components, we can assign which one is which in the references. And this is going to allow us now that every component in our wiring diagram is linked directly to our components in our model. So once we do that, we're able to automatically create those wired connections. And usually when we first input it, it will just be a straight line from one pin to its endpoint pin. And we can then edit those, as I'll talk about in a moment, from there. But really the power of this is, instead of having to try and model out these wires from one place to another and communicate back and forth through email or drawings with the electrical department, they're able to create that entire schematic, and then it gets automatically propagated into Inventor. And then once we're in Inventor, if we want to, we actually can even create wired connections within our 3D model and then push those back over to AutoCAD Electrical and give that to the engineers, the electrical engineers. So if we have components that need to be connected in a different way, or items aren't fitting in the right places, we have a lot more opportunity for that communication visually, moving back and forth between the, again, mechanical and the electrical engineering departments. Uh, Lastly, once we do have those wired connections in, we can create harnessing. So that tool just allows us to model the paths that the wires are going to take through our model. Within Inventor, we can create any kind of fasteners or insulation that's going to group those wires together. And not only does this help us visually kind of make sure that everything fits, make sure our holes are large enough for all the wires that need to go through them, and so on, but it also then gives us the feedback of the exact wire lengths needed for the final product. So then when we get to manufacturing, we're not cutting a 40-foot stretch of wire to try and find out what fits in the end. We're able to cut a lot closer to the exact length that we need, and we're not wasting any additional wire while creating these products. Lastly, kind of within that Inventor AutoCAD ecosystem is we have the factory design utilities. And so this is a separate product that, again, is included just in the PD&M collection. But this allows us to combine our 2D AutoCAD drawings and our 3D models from Inventor in a very unique way. And this is specifically in setting up factory layouts. So we can create a 2D floor plan and place the 3D models on top of that. This really helps to place and size the different components and conveyor belts, handling equipment correctly. When we're laying this out on the floor plan, we can see exactly, what length of conveyor belt we need, and effectively model that within the tool, and then push that back to Inventor for manufacturing if we need to. It also allows us to validate processes, looking at such as the material flow analysis, so we can kind of see the lead time of products moving through our factory and our processes, as well as looking at clash detection. So again, if we have components that didn't look like they clashed on the 2D schematic, but when we got the physical 3D models in there, there was something that wasn't being seen. It really helps put all of that together. And lastly, it has tools for scheduling the installation and commissioning of the equipment once we have designed that factory. So moving on from the factory design, but in the same vein is we have the building infrastructure. And so these last two tools within the PD&M collection are crossovers with the AEC Collection, which is the largely architecture and construction collection within the Autodesk ecosystem. And the reason for these tools being provided in both is because this really is that meeting point between the two. And so, first of all, we have Recap Pro, which uh, Recap Pro is a tool to help you use 3D scanners to convert the existing sites, any existing infrastructure, building, uh, even vegetation, and convert that into CAD data so that you can build your models around the actual space rather than just a uh, fabricated representation of it. Uh, we can then take that data or our other Inventor data, AutoCAD data, and Revit, and move that all into Navisworks, which kind of just works as this uh, central component for everything else to be brought together in. And so we can create that one comprehensive model that has everything from construction, engineering, MEP, all in one place. And one of the key tools of the Navisworks product is the clash detection, because as we all know, when we're bringing assets from several different teams together for the first time, uh, there can be lapses in communication, measurements can be made wrong, things might have changed for one department that wasn't reflected to the other. And so being able to finally put all of those components together uh, and ensure that they all line up correctly, fit together, is really an important step. And that's what Navisworks does. It really works as uh, that midpoint between all of them. However, Navisworks aside, as we move outside of the PD&M collection, there are a couple additional connections that I really do want to talk about. Um, and so the first one is looking at Revit and Inventor. So Revit, again, is included in the AEC collection. However, the communication between architects and construction management and the mechanical engineers is really important, especially for placing any kind of factory or other large scale setups within a Revit model. And that's where the new Revit Inventor interoperability really has come in handy. So rather than having to build everything separate and then try and put it into Navisworks and make sure it all fits, we actually now have the ability to take a Revit model and bring that directly into Inventor. So we can create a view within Revit if we just want a small section of it instead of bringing in the entire model. We can select what Revit families we want to import or not. So, if we don't need to worry about any of the ducting, for instance, we can just turn all ducting off as it's being imported into Inventor. And then we have that Revit model within our physical space of Inventor. We can then place all of our Inventor components, make sure everything lines up, and what even have geometry based off of the Revit model or spacing, uh, so on. And once we've done all of that, because we placed our Inventor components around that Revit model, we actually now have a common origin point for both of them. And so we're able to then create a Revit family from our Inventor components. We can simplify them if we want to, while maintaining all of that information in the bill of materials. And we can export that to Revit and directly place it into our Revit model. Again, usually we'll make a simplified view so it's not too complicated. We don't need all the detail in Revit. We just need the general geometry. Uh, but by doing so, it places automatically, because we did set up that common origin point in Inventor, so we don't have to worry about how it's spaced out. And we then can see, for instance, any kind of clashes within our Inventor or our Revit model, we can have all of that information communicated back and forth between manufacturing and construction. And both of those, again, are associative. So as we make changes, we can continue to push those forward into the other product and keep that communication going, which really is a powerful workflow like we haven't seen before in Autodesk or other products. And then lastly, I just want to talk about SolidWorks. And so while SolidWorks is obviously not a included product in any of these, as it's outside of the Autodesk ecosystem altogether, almost all of the products within the PD&M collection are able to consume or actively use SolidWorks models altogether. A couple of the key examples of this is, start with Inventor, which thanks to AnyCAD, not only can you import in SolidWorks models into Inventor, a lot of times you'll see workflows of people exporting as a step file and then importing, but you actually can work within Inventor to keep the associativity or completely convert that SolidWorks model into an Inventor model directly. So obviously these are very different workflows. You can, if you're looking to keep that associativity, you might be working with a client who works exclusively in SolidWorks, you work in Inventor, but that way with that associativity, even working in Inventor, if they make changes to the SolidWorks models, you can again push those forward into your Inventor model. Or you can convert it completely and then work on it exclusively within Inventor if you are, for example, moving from SolidWorks to Inventor. And then lastly, the last item of the PD&M collection that we haven't talked about yet is HSM Works. So HSM Works is a CAM tool. It's very similar to Inventor CAM. However, it's designed specifically for SolidWorks, and it works as a add-in within SolidWorks, as you can see on the side. And so again, if you're using the PD&M collection, even if you have clients or in-house users on SolidWorks, you're still able to communicate, you're still able to consume that data and push forward these designs effectively. So that wraps up our dive into the PD&M collection for the day. I just wanted to once again bring up this diagram, kind of look at those connections we just talked about, everything from Inventor to AutoCAD, Navisworks, and that factory design utility. All of it really enclosed in one convenient package that's at a really low price point for the industry, and even compared to trying to buy these products on their own. So it really is a very cohesive collection that you get a lot out of, and you're able to look at these different tools, see how they work together, and really make the most out of your technology and your workflows. So now we'll open it up to questions. If you have any questions, you can type them in to the questions tab on the control panel. So we'll give a minute or two now for anyone who has questions to input those before we wrap up. All right, well, it doesn't look like we have any questions at the moment. However, if you do have any questions later, you can always contact us. You can visit our website, www.mt2.com. You can contact your local representative or through our main phone line or sales support at m2t.com. Thank you for attending.